So let's suppose that a ball with mass 20 kilograms is traveling with a velocity of 20 meters per second when it collides elastically with a second ball of the same mass. So we want to find the velocity of the two balls after our collision takes place if A, both of these balls are traveling towards one another at 20 meters per second, and B, the second ball is stationary. So let's begin with part A. So we have two objects that have the same exact mass and the same exact magnitude of velocity. So ball A is traveling in the positive direction along the x-axis, and ball B is traveling in the negative direction along the x-axis. So we know the mass of the object and we know the velocities of the object before our collision takes place. We're looking for two unknowns. We're looking for VA prime and VB prime, the final velocities of the two objects after our collision takes place. So because we have two unknowns, we need two equations to solve for those two unknowns. So because this collision is assumed to be elastic, that means we have the conservation of momentum and the conservation of kinetic energy. So from the conservation of momentum, we get the following equation. Let's call this equation 1. We simply cancel out the m's because the m's are exactly identical. So I get that the sum of my initial velocities of the objects before collision is equal to the sum of the final velocities after our collision of the two objects. Now, if we rearrange these two equations and do a bit of algebra, we get the following equation, equation 2. Now, if you're uncertain about how to get this equation, check the previous lecture on elastic and inelastic collisions. So we have the following result. So the difference of our initial velocities is equal to the negative of the difference of the final velocities. So let's call this equation 1 and equation 2. Now if we add up these two equations in the following way, we get the following result. So I simply add up the left side and I add up the right side of my two equations. So notice the VB's cancel, so we're left with 2VA, and notice the VA primes cancel, and we're left with 2VB prime. So the 2's cancel because they appear on both sides, and I get the velocity VA is equal to VB prime. Likewise, if I take 2 and subtract it from 1, I get the following result. VB is equal to VA prime. So that means my initial velocity of object 1 is equal to the final velocity of object 2. And the initial velocity of object 2 is equal to the the final velocity of object 1. So we know that our initial velocity of object A is 20 meters per second. So that means VB prime is 20 meters per second. And we know our initial velocity of object 2, our mass B, is negative 20 meters per second. So that means the velocity, the final velocity after our collision of object A is negative 20 meters per second. So we see what actually takes place because we have an elastic collision and because the masses are identical. What takes place is these two objects simply reverse in velocities. So this object gives its velocity to this object, and object B gives its velocity to object A. So they switch velocities. Now, let's go to part B. The second ball is assumed to be stationary, and the first ball, ball A, is traveling in the positive direction with a velocity of 20 meters per second. So now we have the same exact equations, equation 1 and equation 2, because we're still dealing with elastic collisions. But now we get these equations because VB, initial velocity of object B, is 0. So I have VA equals VA prime plus VB prime. Let's call this equation 3. And I have VA is equal to VB prime minus VA prime. So I get these equations by simply equating this VB term to 0. So let's call this equation 3 and equation 4. Now once again, I take the sum of these two equations and the difference of these two equations. So I add equation 3 and equation 4, I get the following result. So 2VA is equal to 2VB prime, which is equal to VA equals VB prime. So this basically states that the initial velocity of object A is equal to the final velocity of object B. So our initial velocity, 20 meters per second of object A, is given to the final velocity of object B. So the velocity of object B, the final velocity of object B after our collision takes place, is 20 meters per second. Now, we take the difference and we get the following result. So the final velocity of object A is 0 meters per second. So once again, what happens is, because we have an elastic collision and because the masses are the same, object A gives its entire velocity to object B, and object B, which was stationary, gives its velocity to object A. So object's A velocity is 0 after our collision takes place, and object's B velocity is positive 20 meters per second.